Hello, I'm Dr. Ellie Jameson and we're going to do another science lesson again today. So this week we're going to be finding out about propulsion. So propulsion is, the word is made up of two parts to mean drive and forwards. So propulsion is driving something forwards. And so we want to know what is it and why is it important. So propulsion is driving something forwards. So that's what it is. So to propel ourselves forwards, we use our legs. But animals can also use wings, fins, and even bacteria can move by using long stringy things called flagella to help them swim along. So lots of things move and can propel themselves forwards, and without propulsion we wouldn't be able to move forwards and go to places. So to propel things forwards they need something called thrust. So Isaac Newton's third law of motion says that every action has an equal and opposite reaction. So that means to move forwards, you'll need to push backwards. So when we move forwards, we push the ground away with our legs, and that's what moves us forward. So all of these different ways of moving push something, water or the ground, away from them in one direction to move them in the opposite direction. So we can use this to make machines to either move or do jobs for us. So we can use the power of water running down a river to power a water wheel, which will grind flour. Or we can use the power of the wind to turn a wind turbine and generate electricity for us as well. So we can use these same things to move forwards vehicles like aeroplanes, cars and boats. So we're going to try and make some boats today. So we're going to look at different ways of making this propulsion to move things forwards. So in vehicles, what we need to move something forwards is we need something pushing, so the thrust to propel it forwards, but also we need to reduce the amount of friction and drag on it. So if we try and use some of these boats on this flat kitchen surface, there'll be a lot of it in contact with the kitchen surface and that'll create friction, and with the same amount of power that they'll use to move on water, they won't be able to move here across this kitchen worktop. So they need to reduce friction and drag and to maximise the amount of movement forwards with as little effort and energy as possible. So that's what car designers and aeroplane designers try and work on, is using less fuel to make things more efficient to move forwards. So we're going to use boats on water because water has less friction, so the boats can move along the top of that. And that will help us reduce the amount of energy that we need. So we're going to make some simple ways of generating thrust for these boats. So there's a few different things. So a bit like the water wheel, we made out of elastic bands and lolly sticks. We've put on a small lolly stick in the middle, on an elastic band attached to these lolly sticks on either side. And to make the boat body, I've used something nice and light, so it has to be something lighter than water. So I've used polystyrene, and that's really good because then I can push the lolly sticks inside there. And then we can wind up some power and store it in this elastic band. And instead of like the water wheel using the water to push the wheel around, we will push the wheel around and then we'll release it to make that push it forwards on the water. So as well as that elastic band boat, we can do other things. So we can put a balloon in this. So to make this a light boat, what I've used is just a carton which had milk in it. We've cut it down and stuck it, and then with some super glue, and then held it together with some pegs until it's dried. So we've cut a boat body off there, so pointy bit at the front to make it cut through the water and reduce drag again. Made a little hole in the back here that we put the balloon through. Then we can blow at the balloon inside, and then when it's sat in the water, we can release that air, and the plastic from the balloon will push down the air that we forced into there and push it out the back. So it should come out of the end of the balloon quite fast and push that boat forwards. So this one, so again, I've used polystyrene to make it nice and light. Then I've used just an old pot that I've made a little tiny hole in to put this straw out the back. So this one's going to work on gravity. So we can fill this up using a watering can to fill this up with water in the middle, and then the gravity will push that water down and it will be forced out the little hole inside the pot in the middle. I don't know if you can see that, but I've cut a little hole in there and glued the straw in. So I think the glue might have gone now, but it's still staying in place, held by the polystyrene, and it'll force the water out the back here, and that the water coming out the back there from the weight of gravity inside will push that boat forwards. So also we've got a sailboat here, so This one's really simple to make, so I just used a bamboo skewer, put a piece of card on it, and that can either blow that one, use a pump to push it along, or just use the wind power to push that one along. So what else have we got? So we've got an electric motor on this one. So we just fitted a motor, a simple motor powered by batteries onto this one, and that will turn the propeller here. Now, depending on which way you have your motor attached up, will change the direction the propeller will move in. So one direction will push the boat forward, and then if we switch the connectors around, the other direction will make it go backwards. So we can switch the direction of the motor around by switching the current around on that one. So we've got that one, and then one last one is we're just going to use a bottle with a little tiny hole in the top. We're going to fill that, we're going to power it with chemistry this time. So we're going to use some vinegar in the bottom of the bottle. And then we're going to add into this some bicarbonate of soda. And when those two react together, it will release carbon dioxide. And it'll be forced out the tiny hole. And hopefully, if it stays the right way up, the force of the carbon dioxide coming out there will push the boat along. Okay, so we're going to take some of our boats outside now and see how those work. So I'm just going to put my bicarbonate of soda into a little bit of tissue, so when I drop it inside the bottle, I'll have a bit of time before it makes the gas and starts pushing it along. And that'll just give me enough time to sort it out. Okay, so here we are outside, and we've got our boats, and we've got the smallest paddling pool in the world here to run them in. So with our elastic band bait, we just roll up in one direction. So is that going to be the right way? No, I've done it the wrong direction now. So you have to push it backwards from the direction that you want it to be going to move the boat forwards as tight as you can. And then let that one go in the water. And that one powers us forwards. So we've got a sail boat as well. So this one's should just catch the wind and move it around in our paddling pool. That's quite nice, depending on which way the wind's blowing. Moves in all sorts of directions in our garden. And then we've got this balloon one. So woo, that one moves quite fast when it gets going. Then we've got this one. So this one's a bit difficult because sometimes this one will tip over. So you've got to, this is about a third way of making this one because it keeps on tipping over if it's not balanced right. So I'll just hold it still while I fill it up with the water. Then we get it just right. I should gently just push it forwards with the gravity pushing that water out from that one. Here's our electric one. This one's quite fast. And then, like I said, depending on which way around you've connected your battery, depends on which way around the motor goes. So we connect it the other way around to be able to get it to go backwards. So, and then finally, we've got our chemistry boat here. So I'm going to pop in this little packet. Oh, and get the lid on quick. And then hopefully, oh, it's making some bubbles now. I think if you, the smaller the bottle you get, and the better balance you have, the more chance you've got of pulling it all over there. But we can see some bubbles in there, so that's quite nice. So what you need for your boat, you need something that floats on water, so it's got to be lighter than water. So it's either trapping air inside a hollow boat design, so it floats, or having something which is really light, like polystyrene. Something that's waterproof as well is good. So because this was an old milk carton, it's waterproof, but if you just use cardboard, it'll get a bit soggy over time and won't work properly. And then you need a way of propelling it as well. So try out some different designs, see if you can think up anything different from what we've got here. And if you've got any pictures of your boats, put them online and we'll have a look at them. Okay, thank you.